We will wait up to 1:35 latest.
Okay.
What is the total number registered?
4,000.
Mr. Nithin, 4,000 people are there on as audience.
We have also streaming this session in YouTube also.
Okay.
We are having 1,000 in Zoom.
Okay.
The balance will be in YouTube.
Okay.
Warm welcome and good afternoon, Nithin sir. This is Lavna from the Program Management Office. Nice to have you back, sir, after our last Entrepreneur Speak session. It was very nice.
Thank you.
And we have recommended our partner institute to stream the session if there is more than 25 participants in SKK this time.
Yeah, good.
Because last time we had many people
Will they be able to do that? Will they be able to do that?
Yes, they are logging the Zoom ID in a hall, sir.
So from Zoom you can stream.
They stream the session in a hall, basically.
Yeah.
After your session, we'll have a Slido quiz, sir. After that, we'll have the Q&A. SKK, sir, I think we can start.
Yeah.
Yeah, 500 people have come. We can start, I think.
Yes.
Yeah, okay, start.
Devika madam, can you record the session?
Yes, sir.
Can you record this program, Mr. Nithin?
Yes, sir. Sure.
Right. Please start recording.
Yeah. So I'll one moment.
Just a minute, sir. I'll give an intro.
Yeah.
Good afternoon, all. Welcome to the PALS Industry Special Lecture on Autonomous Mobile Robots, AMRs. I'm Kishore from PALS Program Management Office. I'll be moderating this session today. I would like to reiterate the basic instructions. For easier identification, please rename your Zoom display name as call a short name - your name. Participants will be stay muted and allowed to unmute only during the Q&A session. Chat box usage will be restricted. You can message to the host and the co-host will be enabled only on the need basis. During this session, if you have any question to be asked to the speaker, please write to askpalspmo@gmail.com. The mail ID will be given in the chat box. Attendance link will be pasted in the chat box. Please use the registered email ID to mark the attendance. Participants also requested to register in the Slido at the beginning of the sessions. Now I request Mr. Ravi Jona, PALS champion, to give the opening remarks and introduce the speaker. Over to you, sir.
Yeah, good evening to all the faculty members. Before I introduce the speaker, I like to talk something about his company. This Robotspace, which is established in 2013, it provides a high-tech robotics and automatic solutions for industrial and MSME clients. It is born out of a mission to simplify manufacturing. See, mainly it is concentrating on the in-house design, R&D, and manufacturing industries. Manufacturing industries which it is serving is manufacturing, pharma, defense, railways, and high-tech and automatic and food retail. And Mr. Sai Nithin Krishna Jay is one of the co-founders of this Robotspace, and he is working as a COO. He is an IIT Madras alumni with extensive experience in large-scale data analytics and ERP integrations. His expertise in data-driven decision-making and operation research enhances the efficiency of Robotspace operations. But some of the faculty members who are attached to the Hyderabad hub might have visited Robotspace as an industry visit, which we arranged during 2024-25 and had an interaction with Nitin. Now I request Nitin to start his presentation and take the proceedings further.
Thank you for the introduction, sir. I'll share my screen and start the presentation and walk you through the lecture. So I hope you can see my screen.
Yes.
Yeah. So first, today's agenda, I would like to walk you through and then jump into the session. So the agenda for today is we'll understand what is an AMR and where are they used and why do we need them and how to build one. The most important part is how do we build it. The rest of them are mostly available information, right? And then we'll have a Scoot demo, which is one of our products, which is AMR itself. And I also have a small framework that we can use it for ideas to be evaluated against. For example, when a student comes to you with an idea, how do we evaluate them? So these are all the things that I want to cover today, and I'll take you through one by one. So first I'll start with what is an AMR. So by definition, it is autonomous mobile robot, which means that it's a robot that goes from one location to another. So, and it does not require any human help, meaning it does not require anyone to push it or it can guide it. So it has its own guides by using lidars and cameras, and also it has its own motors so that it can move on its own, right? So how does it look like? So it looks something like this one. So there are wheels and that can put a lot of load, like 1 ton, 2 tons load, and move from one location to another. And it is not required to have any guiding. It has its own lidars that can help it auto navigate from point A to point B.
Your voice is echoing.
Sir? So can you hear me?
Yeah, please go ahead.
Yeah.
Mr. Nitin.
Okay. Okay. So this is a typical AMR, right? And we'll understand what is inside it. So it is just like another car. So when I say car, we need movement and fuel and brain and sensing. So when we say movement, it's basically the wheels. Wheels has motors and drivetrain. How do we make them move? Make it move using motors and wheels, right? Then fuel most of the time it is battery, because that's the easiest way to handle robots, right? And then there is brain, which is controller. So it's basically a computer that is sitting on it and taking all the decisions. And for sensing, so what do we have to sense? We need to see the obstacles. We need to see any path. So those are all covered under sensors, which are basically lidars and cameras. Right? So a simple block diagram of how it looks like, right? So we have sensors which are sitting on the top and various um, sides of the robot to detect any obstacle and also find the path of it, right? Then comes your controller, which is the brain, the computer, and then you have your battery, which is powering entire system, and then you have wheels and motors. So this is the typical AMR that will in a block diagram state. Okay, and now we have, where do we need them? So we know that warehouses need them. We saw just a picture, right? We need it in factories to move material from one location to another, or hospitals for serving some medicine or food. Those are also there. And then airports, you might have seen already, there is robot vacuum cleaners that are cleaning the airports, inside the airports. So those are there. And for hotels also, in China, you might have seen some videos there. The Instead of, if you ask for a water bottle, the robot gets you to your room instead of a person. So that is hotels and restaurants. We have already seen robo caves which are serving food in India and also abroad, right? So there are multiple places where AMRs are used. So I just wanted to show you different pictures so that you can relate to them, right? So this is one type of robot which has tugging capabilities, meaning there is no load on it. It is tugging. So when we say tugging, it is complicated than a typical load on the robot, because when it is turning, it has to remember that it is tugging something and take the decision accordingly, right? So it has to take care of turning radius, things like that. So it's just like, we are driving a car and we have a trailer behind it. How do you turn it? You can't just turn like you do not have a trailer, right? So you have to be careful and you have to give additional safety systems, and also the radius has to be increased. Then these are different kinds of AMRs which have lifter on top of it. So these robots have lifter which will lift the material by going underneath it. So some of this one is going underneath the shelf and picking it up using a lifter, right? This one, people are placing material on top of it. This one also same, it is taking it from a conveyor. This is using a forklift. It's actually a pallet. It goes under the pallet and take it. So there are multiple different types. So I just wanted to show you all of these things so that when I'm talking about AMR in general, AMR can be either this one, either a tugging one, or it can be a material delivery, something like this. This is a forklift AMR. So you might have seen forklifts, but this has the capability of autonomous mobile robot, right? So meaning there is a lidar on top of it that is ensuring that it goes without crashing into anything. And this forklift is, why do we need forklift actually? Because usually pallets look like this one. To pick up this one, the easiest way is forklift. So forklift has the capabilities to pick any pallet, and adding AMR capabilities on top of it helps it to navigate within the factory or warehouse easily. Because yeah, so this is a delivery robot, right? So this is also an AMR. It is outdoor AMR, right? It is outdoor delivery. It delivers food. There are multiple use cases for outdoor action. This is one of the robots that we have built actually. This is doing a survey. So this is also an outdoor AMR. It is doing survey of some site, and then capturing all the data, and it will give it a report. So this is another robot, and you might have seen this kind of robots already in your houses, right? So robot vacuum cleaners, which are also AMRs. It has the same capability as an industrial robot. It is just small, and it has its own vacuum capabilities add on top of it, right? So this is a typical household AMR. And these are the service robots that I was mentioning in the restaurants. So people in the kitchen load the material and click a button, and it will go to the table and stop it. So these all AMRs have fundamentally autonomous navigation, meaning it can go from one location to another on its own. It does not require any human intervention to go from one location to another, right? All other things like picking the material is an add-on. Picking the material, placing the material is an add-on. If this robot has to say hi, that is an add-on. It does not have to say hi. The basic platform is same for all of them, only the application changes. And this is medicines and all. Hospitality is also using the hospitals also use this kind of robots, right? And little technical on this one here. So Scoot is made by Robotspace, and like any other robots, this is also same AMR capabilities, but what we have built is a platform. So we did not specify you should only use it for manufacturing, you should only use it for warehouses. This can be used anywhere depending on the requirement. We can use. So when we make this one robust, any application on top of it is just an add-on for the user. So it can be a restaurant use case, it can be a pharma use case, it can be a manufacturing use case. So these are all things that you can improve on top of the platforms, right? I'll quickly show what Scoot does. A live demo will help us understand how the product is. I think we have Bharat joining the call. I will stop sharing so that his video can be visible and we can pin it. Yeah.
You are not audible.
Yeah, actually, we are. I'm asking Bharadwaj to join the call.
Okay.
Yes, I made him co-host also.
Okay. So he should be able to show us the video of Scoot live demo. I just have a question. If were you able to see my screen share earlier?
Earlier it was visible.
Okay, I just now stopped, I guess. Okay.
Yes, just now you asked.
Okay, we have few hands raised.
Don't worry about all that. We will do it at the end.
Okay.
I think Bharatwaj has left the call.
He'll rejoin maybe.
Okay. Hello.
Yeah. So while Bharadwaj joins the call, I just wanted to have one more point that I wanted to discuss. So when choosing a AMR, or when we are planning to build an AMR, so couple of things that we need to keep in mind is what is the payload requirement, because that decides the
Actually, the problem is the Zoom has reached its limit of 1,000. So Bharatwaj can't able to join.
okay.
He'll be redirected to YouTube.
So what do you suggest we do? Should I?
He can only watch.
Yeah, actually, we can. I want him to join so that he can show the demo, live video of the demo.
Yes, he has joined, but he left again. It has reached its full limit. It will be automatically redirected to YouTube.
Okay. Okay, so okay. So is there any other way we can show this? Maybe?
If you have the video, you can run it.
I'll see if I can ask him to join another Google Meet.
And you can show that Google Meet from your screen.
Yeah. Yes. Yeah, Bharat. Okay. 1 second. I think. Yeah, I hope you can see the screens.
Yes.
So this is Scoot platform. So Bharat, can you walk us close to the LiDAR? So the black one is the LiDAR on top of it, right? So this is the LiDAR, and there are motors, 2 motors, and within the wheels itself, they are called hub motors. And then there is a caster wheels that are inside. They are like dummy wheels which are which have the ability to rotate. Okay. Yeah. Bharat, can you walk us close to the LiDAR? Yeah. So this has a LiDAR here. And can you show the camera also? Yeah, this is a 3-dimensional camera which has the depth information. So what happens with the LiDAR is, can you go back to the LiDAR? LiDAR has only 2D plane. So it can only cut through the 2D profile, and it can detect different profiles only at that height. But if there is a person or something, some material that is above it, it cannot detect it. So for that reasons, we use a 3D camera. So the camera is capable of this camera is capable of detecting whatever is around the robot and give us the obstacle information. It's a you can see it is actually rotating. There is a rotation that is happening in the camera, right? So let us have a quick demo. Can you ask it to move from one location to another, Bharat? And do you have someone who can obstruct it?
Yes,
Can you ask it to go to a different location? Maybe show it in iFactory OS. So this is our experience center. So we have iFactory OS here. That is, yeah. Can you go close to that and show the application? So this is the application that is controlling the school. So it has different options. It can go to home, experience center, project base. Currently it is at project bay 3, I believe. So you can ask it to go to second project bay. It's okay. It's in project bay 1. It is going to project bay 2. So when you click on this one, it'll can you show us the robot? Yeah. So I think someone is trying to block the road. So if you can, what it will do is it will find a different path, right? So it will find a different path and it will navigate around any obstacle as long as there is space for it to move. So it can, it has come here and it has docked. Can you show us the map view of the robot? So what happens is when we map this entire area, you will get a map like this. This is effectively the plant layout that we have here. So you can see this blink is where it is currently. So if you click on a different area, it should be able to go from there. So it's a flag and basically it's a goal. So it goes from that location to a different location. So we can control that from different interfaces. So what actually happens, what I think everyone would be interested is, so what's happening is, how does it do the localization? How does it know where it is, right? So that's something that we are more interested in, right? Can you keep it here? Yeah. So what happens here is it projects a lidar in all directions, 360 degrees. Right? When it projects, initially it has a map. This is the map it already has. Now, when it is at this location, it projects a map, lidar, and it will try to see. It will basically check what is the distance from here to this area. So when lidar is rotating, it will have. Bharat, I think your video is lost. Yeah. So when we, so what happens is lidar, when it emits laser, it will compute the distance from this point to this point, this point to this point in all 360 degrees. It will do. So when it does that, it has the inbuilt algorithms to compare it with the walls. So it will know where the walls are, it will know where the corners are. So automatically it will automatically align it to the map and understand that it is at this location. Otherwise it will not be able to know, because it is not GPS, right? It does not know where it is. So this is helping it to localize. And second thing that it does is, when we give a goal at a different location, can you give a location near to project bay 1, Bharat? Yeah. So the moment we click on that, what happens here is from goal to this, from current scoot position to goal, it already knows this map. It already knows the obstacles. So what it does is it will find the shortest path by avoiding those obstacles. When it does that, there might be a chance that some human person is coming, or somebody has put some material there. So that is where SLAM comes into the picture. SLAM, simultaneous localization and mapping. So if there is a new material that is coming on its way, it will do a localization then and there and avoid that, and see if there is an alternate path to the goal that was created. So that is the fundamental of this entire robot. So it has the ability to localize based on the walls, and it also has the ability to avoid obstacles in real time. So that is two. And it also has something called IMU, inertial measurement unit. Basically it will tell the robot where it is, whether it is at from starting point. It will know exactly where it is moving, whether it is moving sideways or so. LiDAR plus camera plus IMU plus odometry data. So like our cars have how many kilometers it has moved, same way the Scoot also will have odometer, which will tell how many meters it has moved forward. So based on all this sensor fusion will happen, and automatically it will be able to accurately position itself in within any room, right? So that is how it is, the fundamentals of the AMR is. Bharat, I think you can turn off. Yeah, we'll go back to the presentation. So coming back to our presentation. Okay, so that's done. So now we after we understand architecture, how it works and all, now why do we need AMRs? We all know that labor is shortage already, and speed and throughput can be improved with robots. And safety aspect, some areas you don't want people to go, so you can have the robots. And basically there are a lot of industries that use manual labor to pull, so we can have these robots as an alternative that can do this. And then these are flexible. So this is very important actually, right? There is something called automated guided vehicles. When we say automated guided vehicles, these are like trains. It will need a guide to move. It's not like a train, it is a tape. Like you might have already seen line follower robots, right? This is a industrial version of it. There can be a tape which is black color tape. There can be a magnetic strip that is having magnetic material in it. So this, based on that strip, it will keep following that path. But unfortunately these robots do not have the capability to, they don't have brain, they just keep going, right? Now problem with this is, if there is any material that is on its way, there is nothing it can do but to wait until it gets cleared. Now AMR has the ability to dynamically change its course. If it is a controlled environment, AGVs are good because it costs less and also can do higher speeds. We don't have to worry about someone coming in between, right? So AGVs are suited for that kind of applications. But AMRs are for dynamic in nature, dynamic environments where that we don't know what will happen or people movement is there. So AMRs are something that are used for that kind of purpose. Okay, now coming to the how do we build one, right? So now you have three departments that are doing this activity. One is mechanical, second one is electrical, and third one is the software department, software or the robotics department. Now, even one person can do all three of these things because there is a lot of open source material that is available. Okay, going a little bit in detail onto the mechanical aspects, right? So you need to understand what are the requirements of the robot. What is the payload requirement? For example, I want to move a material of 500 kg. So the kind of motors, the kind of battery backup, and the kind of speed that you want to go, acceleration required, decides the motor capacity and the battery capacity. So, and also your entire structure dimensions also depends on the payload and your type of material. You are using pallet means you need a 1.2 by 1.2 meter size robot. So when you need a for example, you want it to be used in hospitals, you don't want that kind of big robots. You want a very small footprint that can go in small tight areas. So that decides your entire mechanical structure, right? Then comes your the motors and torque calculations are all part of this weight and payload and the accelerations, right? Okay, I'll jump into electrical. So before that, I think we have something little more on the mechanical itself. Um, so in mechanical, you have your frame design. So some mechanical designer have to design the frame. It can be using aluminum profiles or typical rods that you can weld them. But someone has to design it in a CAD software. So this is no different from designing a car, but it is a very small car, right? You have to design it and do the load analysis also. You can't make very big one, right? So what we'll try to do is try to minimize the usage of material, and weight also. Weight of the entire robot should be minimized so that half the battery should not be drained because of robot's weight itself, right? So we need to ensure that what is just sufficient is what we should design for. So that is frame structure. And then what kind of materials we can use. There are options of aluminum extrusions. If you want a temporary setup, aluminum is a very great option. We'll also see those aluminum extrusions. It looks something like this, I believe. So aluminum extrusions will look something like this. Most of you might have seen it, worked with it, right? So there are sheet metal also, something that is used for the body exteriors. So sheet metal laser cutting is something that you do the laser cutting and then do the bending so that you can have the entire structure that is made out of sheet metal. And they also machining for your hub, motors, couplers. So there are a lot of design techniques and the fabrication styles that we need to use to make this robot mechanical, right? So I'm showing an AMR again so that we can relate to what we just discussed. Now you have on the left, you have all your aluminum extrusions that are extruded, right? So these are all connected to accommodate for the load bearing. So this is how you construct with aluminum extrusions. You take a bunch of aluminum extrusions, join them together using a die cast. There will be some simple way to connect them without welding anything, right? So this is something you can Google easily. You'll find how the extrusions work. Then you can see on the right there is sheet metal. So all this is an Indian company. They also make AMRs. So this is a sheet metal, right? Even our scoot is also sheet metal on the outside. So the olden days, so all entire car used to be like sheet metal. Now you have fiber, everything. So depending on the scale, you can go for sheet metal or the fiber, right? So that is one. Okay, I'll before jump into electrical. Yeah. So we discussed about fabrication techniques, right? There are welding, there is machining, and laser cutting and bending, and bolts using for all aluminum extrusions. Bolts are used, T-nuts, and so the fabrication is done now. Now mechanical aspects are done. Now electrical. Coming to electrical, you have your sensors, you have your power distribution, how the battery should distribute to different modules within it. Not everything will work at the same voltages, right? So that is one constraint. I mean, one concern that you need to ensure that the systems involved, the computer operates at 9 volts to 36 volts, for example. The motors operate at 24 volts. Your some sensors operate at 5 volts. Some things only operate at 24 volts. So how do we ensure that your battery, which is 24 volts, can do all these activities? We can't have separate batteries for separate systems. That will be very inefficient, and also it is difficult to charge them, right? So that is something that we need to think about. And motor drivers, how do we drive the motors? So all this wiring. So I'll jump into the electrical again. Yeah. So again, splitting electrical into three different power. Second thing is power or the battery energy, and then there is sensors, sensing hardware, and the controllers, the motor drivers, and various other things. So when you come to power or battery packs, so battery pack, we need to decide the voltages that are required and the capacity, how many amp hours we need, how many amperes. What does an amp hour mean? I mean, it's a very simple definition, but I just want to say, if I say 100 amp hour battery that I am having on my Scoot AMR, what does it mean? How did I budget this battery? So I need to understand what is my consumption of motors, what is the ampere that is being drawn, and the amperes into the voltage that is um, that is supplied to that system. So if my motors are drawing 3 amperes and 24 volts, so what is the ampere hour rate, wattage? So this computation should happen across the systems, and when you put everything together, you will know that whether your battery will last for 10 hours, 5 hours, or only 1 hour. So depending on that, you will be able to design your battery, or basically spec out your battery and get the right battery for your robot. So that is the power and energy system, and you will have charging mechanisms. You want fast charger, you want normal charger, you want an auto docking charger. So there are multiple ways to do this, right? Then comes your sensing hardware. So you need lidars, depth cameras, IMUs to understand the direction. Basically, IMUs are more of an orientation. It helps in identifying the orientation, because you will only be able to know the where you are, but which direction you are headed is very sensitive information that is available at the IMU sensor level, right? And wheel encoders helps you in terms of how much you have moved. So that is there. Then your control drivers, so your motor drivers to drive your motors. What is the configuration? How many pulses you have to give? Those decisions happen, and your drivers are configured accordingly, right? So any e-stop mechanisms. So I think we covered power distribution and microcontrollers. Anything that you want to be in real time. So you use inputs and outputs, right? So that is MCUs, and your e-stops and safeties. So for example, material is on the AMR, and it is for whatever reason, some configuration mistake or something, and it is going and crashing into something. You need to have a quick e-stop to kill the robot and stop it immediately. So those, when we bring e-stop into the picture, how do we wire them? Which all systems should shut down, which all systems should still be alive? So those decisions have to happen at the electrical drawing stage, where you will have an electrical drawing which will have block diagrams of which system is connecting to where, and how the power is between distributed, and where are the e-stops. Those are all part of the electrical drawing. So a typical battery and hub motor. So this is a hub motor which has motor inside, and inside the wheel. So all we need to do is give pulses and it will move, right? And then this is one of the leading lidar. So what it does is, it depending on the requirement, whether you want a 10-meter distance detection or you want 100 meters. When we are talking about warehouses, we are talking about 100 meters of shed. So we need lidar that is powerful to detect this wall and the other side wall also. So that is the kind of lidar that we need to use. So we'll go for something we like Velodyne, which is a very big company that has large ranges. So you need industrial computers. Unlike our laptops, you need computer that can sustain this kind of computation, and also does not heat up, does not break. So we need industrial computers that can that have heat sinks and all. So these are all that are going inside the robot, right? So we'll before I think this is done now. Yeah, coming back to software. So how do we the third part is, these are all done, electrical wiring is done, mechanically robot is ready. Now we need to write the actual software that will do the job, right? The job of going from one place to another, the job of planning the path, the job of taking the decisions on the fly. So those are all part of the software. So I'll go back to the software. Yeah, in software there are again three divisions. So basically you have to use some framework. ROS2 is a very famous framework that is very standard nowadays. It's easy to learn also, because there is a lot of open source material that can be used. So using ROS2 framework, once we understand how to set it up, we can write drivers. So these drivers are required to communicate with your motors. So what actually ROS does is, it can take inputs from your lidar directly. So when you say my lidar 0 degrees, I see obstacle at 1 meter, 1 degrees I see something at 2 meters. So this kind of information, the information of the lidar is sent to ROS2. When we configure it, it will understand that robot is at a certain location, and it is seeing obstacles in all 360 degrees direction, right? So that is an input for it, and your encoders are an input for it. When the wheel moves, that is an input for the robot. So it will understand that, okay, if right tire moved forward and left tire moved backward, what happens? It will rotate, right? So it will rotate in place. So that understanding is already inbuilt in ROS2. So it is called differential drive, and it does know the what is robot doing. If both tires are moving forward, it is basically moving forward. The robot is moving forward. So how much moving forward we need to configure, because software does not know what we have made in the mechanical side of things. We will have to tell my wheel size is 150 mm. If I rotate one rotation, means I will get 2 pi r, right? So whatever the length that comes, that is the distance that I'll be covering if I do one single rotation. So those things are already available in the framework. We just have to configure what is my robot size, what is my wheel to wheel distance size, what is my wheel diameter size. So this will help ROS2 to understand what is the robot. It's like, just I want to take one step back. So if I am a person, I want to walk, I will keep assessing if I will fit in some road or not. For example, if there are a couple of chairs, I will know if I will be able to go through it or not, right? How do I know? I know the size of my body and I know the gap that is available. Same way, ROS2 also should know first that what is the robot size. Then it will decide whether this will fit in the gaps that are available based on the LiDAR data. So that is the ROS2 framework is doing most of the work. We'll have to just configure it, right? And simulate. So before simulation, I'll just skip this part and I'll go to simulation. So when we say simulation, Gazebo is the simulation layer. What happens is, whatever you want to run the program, you will write some programs, you will have some obstacle avoidance program that you have written. What you can do is, you can simulate ahead of time before running it on a real hardware, because when you run it on real hardware, sometimes it may crash into something and damage something, right? So, or you can have multiple students run the simulations in their Gazebo, and then you can only have one hardware that you can use it to flash the code and see if it is working as expected. So this is a very good way to analyze before you do it on the real world. So simulation is there. Like I said, device drivers is basically talking to the external hardware. So the hardware can be motors, cameras, lidars, anything. If it is a forklift, that is, it has to move up and down, we'll have to write a driver to do that activity. So that is the that is all about the framework and how do we configure it, right? Then the perception. So basically, when you say perception, the how do we see it? How do we how does the robot sees the world? It sees through cameras, it sees through lidars, and it has some other software layers like I mentioned earlier, SLAM, simultaneous localization and mapping. So it has the capability to simultaneously localize, meaning it knows where it is in real time, and also if it has to change the course of the path because there is an obstacle in front of it, it will do that by simultaneously doing this algorithms helps the robot to simultaneously take a new path, right? So there is that. And then so SLAM is more like a localization, and the path planning is one more item which I said. So how do we plan from one location to another? It understands based on the original map that was created, but that path can be changed on its way. Okay. Then you have your sensor fusion. What is sensor fusion is basically how the name suggests, it fuses multiple information from lidars, laser, the IMU, the odometry data, so camera data, all put together. It will understand that okay, there is an obstacle, there is an how much it has moved. All that information is part of sensor fusion. So then you have your behavioral trees. This is basically, you'll have to have some behaviors, like for example, in your robot vacuum cleaner at home, so you will have some no go zones. So you will say, don't go in this area, don't, you'll have some markings, right? What these are all not available standard. They will be available, we have to write some additional layer of software to enable them and be able to use it. So that is one item. So, and this is, we need to understand that ROS2 is designed to do go from one location to another only, right? Now we have a task plan. So we have something called, you have a very specific use case. For example, you want to go from point A to point B, and then point B to point C, point C to point D, and wait at each location. You want to wait for 5 seconds to collect some data. It can be some sensor data, atmosphere, AQI level or something like that, right? That task planning is not generally available standard because it is not intended for that purpose. So we'll have to write some more software to drivers and some packages to do that activity. And fleet management, motion control is also similar. Fleet management is basically, if you have more than one robot, so it is very difficult to manage them. So we need to find a common location where we can control all these robots, coordinate them. How do we ensure that they don't crash into each other, they don't attend to same activity? So these are all part of fleet management that we need to that we can also do that, right? So these are, ROS2 is something that we need to if this is the base. Nav2 is for the navigation, right? And Gazebo is for the simulation. I have a list. So this is a typical Gazebo view. You can create the entire world inside it, and you can have any robot that you can simulate. So you can see this is a laser view or LiDAR view, and a person is there and it is obstructing the laser. So automatically the robot will know that this is the distance, there is an obstacle. So it will do it will take the decisions based on that. And the reason why I showed this Gazebo is that all the simulation can be done ahead of time before you deploy it on the actual hardware, right? So there are very good resources that are available for learning. So I just wanted to list that also. I think we have spent a lot of time in slides. We will also have some Q&A session, I guess. So this is I just wanted to have learning resources for ROS2 and NAV2. There is a very good online tutorial where you can gather this. And all mechanical design, I'm sure you might be already using Fusion 360 or SolidWorks if available. So that is one item. And then there is a hardware robot. Basically, I just want to show you this one. This is another robot that is standard available in the market, which is specifically meant for learning purpose. So these robots have very good documentation, and these people have been there for a while actually. So when ROS started, these people started, and this is something like you don't have to worry about how to bring up the robot, make a robot. You can just plug in and test your code. So this is something that I thought will be helpful in this discussion, right? So that's all from my side for the AMR, right? I hope I covered enough to give you some idea on how to make one. I have a quick something called some framework. Just thought I will also share that one, and then we can jump into the next. So what we thought is, you might be getting a lot of requests from students where they'll have some ideas that they want to work on, right? So we thought of having a small framework that you can ask the student to do this activity and see if it makes sense after this activity is done, right? So we just have this is something called 5P framework. Basically, what is the problem? Is the pain real and sharp? So most of the time, once you learn ROS, the obvious next step is to make a robot. But that should not be the approach for uh, for a business idea or anything, right? So we need to first find what is the problem that we are trying to solve. So that is something that you can evaluate first. And who is the people that have this problem, and how badly they want to solve this thing. Maybe there is problem but they don't want to solve it, they are okay with it, they can manage it with current setup that they have. So this is something, this is same what we do at business also, right? We, whenever someone comes with a requirement, we'll try to see if this is a problem that they really have, right? And who is the person who is raising the request? I mean, who is the people that has the problem, right? That is so is there any proof of concept? So when we say proof, does it work, right? Does it solve the problem that is intended, or is there a different problem at all? And then payoff. Okay, these are all fine, but what is the cost of it? How much it would cost, and would it make sense for the user to buy this one at that cost? So what return on investment is something that is very important whenever we are working on some idea, right? So end of the day, whether it is possible, what is the possibility of making it? So we can't make rockets every day, right? So if some problem statement requires rocket to be made, it it requires that kind of effort. So what is realistic, we'll have to understand and evaluate. So this is something that I thought you can apply it to your students and give some more examples on what should be the, and also have them do some surveys to see this is actually a problem before they start on their venture of trying to address this problem. So I think that's all from my end. I'll stop my share. I'll take some questions, I believe.
Can we go to the quiz, or you are going to continue, sir?
1 second. I think we already shared the questions. I guess.
Yes. I got the 5 questions you have shared with me.
Okay.
No, you're going to continue the lecture, or that's it, sir?
So I'm done with the lecture. I can take
Okay.
QA.
Okay, wait a minute. We'll go for the quiz, then we can go. Devika madam, can you paste the link in the chat box, please?
I'm done, Kishore. I have already pasted.
Okay, thank you. Request the participants to join the Slido quiz using their registered email ID. It is a timed quiz, total of 5 questions. At the end of the 5 questions, we'll have a leaderboard. So it will work like who's going to answer the correct question in a short duration. For each question, you have 20 seconds duration. I request the participants to join soon. The quiz is compulsory to get the certification. So I request the participants to attend the quiz. Participants who are attending in YouTube also can join in the quiz. Once it reaches 1000, we can start the quiz. Okay, I'm moving to the first question. Imagine an AMR is carrying a pallet and a worker successfully walks into front of it. What it should the AMR do? Okay, most of you answered B. We'll see the answer. Okay, the second question. Okay, answer B has been given by most of the participants. Okay, the third question. Okay, got the right answer. Fourth question. Okay, and the final question. After this, we'll have the leaderboard. Okay, we'll reveal the leaderboard. Okay, Congrats to the participants who have answered the questions. These are the top 5 participants who have answered the questions within 16 seconds. Vijayaraj has answered all 5 questions in 16 seconds. So I think Vijayaraj and Danshita has made the record. Thank you for attending the quiz. You can come to the Zoom screen. The session is open for Q&A. I have opened the chat box. You can type your questions in the chat box. Also, we have given a new attendance link as a Google form. You can fill the attendance in the given attendance link. Participants, type your questions in the chat box. Also, you can raise your hand. We'll be able to unmute you. Please type your questions. Okay, Mercy have raised a hand. Mercy, you can unmute now. Can you unmute and ask your question? Also, I request the participants to type your questions in the chat box. Participants, the chat box is open. Okay. Punavasan, you can unmute.
If you don't have a question, don't raise your hand.
You can also type the question in the chat box. The chat box is open. Okay. Willy. So there's a question from Ratish. Sir, throughout the session, in which field the AMR can do this job?
Okay. Which question is, where is the question?
It has been come that I'll paste in the chat box.
Okay, I have one question here. In what way AMR used in hospitals? Okay. So in hospitals, what happens is during Corona time, COVID time, it was very difficult to attend to all patients, especially in this contagious wards, right? So what happens is these kind of AMRs, you can put material, food or some medicine on top of it and ask it to go to different beds. So it will go there and give whatever is required and come back. So there is no exposure of human to human contact is not there, right? So that is something. Okay, that I think. Yeah. Next question.
So throughout this session, in which field this AMR can do this job?
Which job?
Also a working of AMR at a scheduled time, sir, instead of a specified time.
Okay. Okay. So working with AMR at a schedule. So basically scheduling and all those things are some things that are not part of the original framework. The base framework will not have these things. We will have to write a scheduling software outside and trigger the requirements. For example, I want to call the robot to come to my location, but it should only come when the material is ready, right? So when some material is ready, I can schedule at 5 o'clock. I should write the code outside. After 5 o'clock is done, you need to raise a request, API request to call the robot. So that scheduling will be done through a different program, right?
Okay, sir. So there is
Yes,
another
Mercy, you
question.
want to speak?
There's other question. Explain AMR. That's not there.
AMR briefly once.
Yes, already it has been explained very briefly. Okay, sir. I think we are done with the questions.
No, I have a question.
Okay.
I have a question.
How is generative AI expanded to impact future autonomous robots? That's a question.
So basically, AI, how it is going to be in factory fields is basically. So we need to take a lot of on-field real-time decisions, right? So real-time decisions means AI is very good at taking real-time decisions on the fly. If it is not structured, if it is not first click this button, second this button, that third button, we already have PLCs from very long time, right? So we can use PLCs, but if it is dynamically changing, some decisions have to be taken like humans, AI can do that. And with the help of robots, AI on top of a robot can take decisions easily. So AI and robotics will go hand in hand. AI will not replace any robot. Robot will not replace AI. Unlike what's happening today with software, robots are here to stay, because this is actually called physical AI, physical devices. Basically hardware is physical, right? So physical is required to do some jobs. You have to move material, you cannot do it with software, right? You need a hardware to move material, so we need to do that.
A number of questions for you.
Sir, please. So next question.
Next question, can AMR continue operating safety if their sensor temporarily fail or become blocked?
So there are some return to base type of options, which what it will do is it knows how it went. It can come back in the same path back, but in the meantime something else came in the bit. I know some people put material there, that then it is advised to stop there. But if you know for sure there is no any material in there, you can ask it to come back in the same path it has gone. So it will back trace the path that it has gone, and it will come back without any issue. Sometimes when we use this kind of things, it's not in sensor issues. We use it in outdoor scenarios where we lose connection. When we lose connection to the remote which we are using to control, so it will automatically trace back whatever it has gone.
Okay. There's a Judson. Can you see the question, sir?
Yeah, I will try to check. You are using Gazebo simulator with ROS while running buggy in track using product, slows down while turning and returns to axle. How to make the buggy run with the axle speed with? So in Gazebo, the question is, I think during turning it is slowing down. So it is meant to slow down in turns, because it will not be able to maintain the position if it is at that speed, right? So that is the reason it is meant to slow down. But if you have a configuration, you might want to check your configuration and see if the maximum speed is already utilized. Because what happens is the obstacle avoidance and all those things will work only at certain speeds. Beyond that, it will not have time to react, it will crash. So that is the reason it has a speed limitations. Okay. So there is another question. Using
Yes, there are
AMR.
few questions.
Yeah. Using AMR, how to implement any project for career enhancement? I would suggest to start with a simple AMR that is that can be done using a simple computer also. Computer. First, you can. I mean, this robot can be done as a simulation only. It can be done with a mechanical real robot also. You can have hardware assembled motors. So if you do not have the knowledge of electrical side of things, what you can do is, like I showed you one robot, that kind of robot you can purchase, that can be used as a platform to learn on top of it, because not everyone is well versed with electronics and mechanical. So software can be done separately. Electrical people can just do electrical work, and mechanical people can just do mechanical designing only. So that is there. And then so there is another question. It was direct message. So in what way AMR techniques may be used in autonomous cars? So autonomous cars are even complex in terms of the safety systems that they have. So they do not rely on the lidars for localization. It uses lidar for obstacle detection, but it has something called GPS. Like our phones have GPS, there is GPS, which is powerful GPS actually. It will be able to locate the car in 1 centimeter accuracy also. So that GPS is used for the cars. So GPS is the primary thing that is used for autonomous cars. The lidars are safety systems that are obstacle avoidance, make sure that it does not crash into something, that kind of yeah, applications. Okay, will AMRs replace the warehouse workers or will it create new job roles? So actually there are these are basically automating the push cart people. So it is not, it's a very fatigue intensive job. There is no point in having this kind of job where it's a back breaking job, you have to walk a lot, right? So these are the jobs that are some jobs are being replaced as part of this one, fatigue related. Some jobs are like forklifts are very dangerous equipment. If you don't operate properly, it will damage the property or human lives also. And it is very difficult to get forklift operators. It is very skilled job. So what we can replace the forklifts, which are, because if you don't get people, you'll end up having a situation where people who are untrained will use that forklift and it will crash into something. So that kind of scenarios can also be averted. Then so whether it will create new job roles, see, some jobs are being taken away to reduce the load on humans. So obviously they will be doing something else which are better than just pushing the cart, right? And that is one of the reasons that I put the image in the slide, to show that this is the job that they are doing. It's a very fatigue job. Okay, next question is, what skills should students develop to start a career in robotics and automation? So the skills, any robotics engineer will have mechanical designing skills, even for basic skills, electrical knowledge, how to do the power distribution, how to read a data sheet. If a sensor is given, how to understand the sensor, how to read information from the sensor. Those are the things that are required for electrical aspect. And software, robotics, if you want to be in robotics, ROS2 is must. Then can a robot tell the difference between a temporary box on the floor and a permanent wall change? Yeah, it can. Yes, it can tell the difference, because it will also collect the information, between two runs. If the box is there in one and not there in the other one, then it will know. And if there was a wall before and wall is removed now, it is not there now, it will also be able to know that the wall is removed. But with that information, what do we have to do if you want to go in that area? Then you'll have to remap it, recalibration, right? That is it. Okay. Which programming language? Yes, Python, C++. Yes, these both are most important for the robotics. They are very essential. So in which sensors are required most important for AMRs? LiDAR is the most important one. Then LiDAR will only give you 10 centimeters accuracy. So your robot can be this way or that way in a desired location. Then comes your odometry, and your IMU will do all put together will give you the highest accuracy. Okay, then since AI is becoming central to robotics, what skills should students develop now to contribute to the future of autonomous mobile robots, particularly in aviation? So at this point, any student should be able to spin up a robot, work on any robotics code, robotics operating system, ROS2 code. They should be well versed in ROS2 so that they can work in robotics. Okay. Now, so is AMR has future for ECE student? So the beauty of robotics is that it does not discriminate against any department. You can be a mechanical student learning ROS to be able to make robotics. If you can be an electrical student. The only thing is communication systems, ECE students or electrical students, they have a little edge on top of the other people because they can actually make the robot even using a small plywood piece, because they know how to connect things, right? So they are very core to the robotics. And then software is a must. Software is something anyone can learn today, because with AI you can easily learn any software. The coding is very simplified now. So is pursuing MTech a good choice for this field? It's a very subjective matter for MTech, because there are very good universities in India and abroad where they do a lot of research in terms of robotics. So I mean, if the university is right, you should take up MTech. Yeah, I would.
Okay. I think we can close the Q&A session, sir.
I have a question here.
Yes, sir.
Mr. Nitin, I have a question.
Yes, sir.
You see, in a multi-product line, multi-model line, for example, Maruti,
Right.
they have large number of varieties of cars going in the same line, same manufacturing assembly line.
Right.
There is a large warehouse from which parts have to come.
Yeah.
So those parts have to be delivered at different locations in the assembly line.
Right.
And for each car, each one is different. For example, starter motor, it will be different from Wagoner, from Swift or whatever it is.
Right.
Now, will all these AMR, can all these AMR be used based on the scheduling done for a particular day, particular shift, and pick up those items from there and deliver to the shop floor at the right place on a JIT basis for every 10 minutes or every 10 minutes
Yes, sir.
or every 1 hour,
Yeah.
so that just in time it is delivered.
Correct.
Is anybody doing this in India?
Yes, sir. I mean, we are doing already, but this is something that is a very specific requirement. Not in I mean, we are not doing it in automobile. We are doing it for some other use case, but similar use case. Like you said, yeah, we are in discussions with Electra, for example. Electra is also an automobile bus manufacturer. So at each bus station, I mean, when the bus is being made, at each location they are at one location they are putting the front glass, another location they are putting front lights, they are doing something, there are different activities that are being done at different stations. Like you mentioned, so we can integrate barcode systems that can detect if it is the right material that is going now on the AMR and go to the desired locations at the desired frequency. So, and it will drop off there. So there will be another station there that will collect the material from this one.
Okay. Now, another point is, what is the difference? What is the cost comparison between a forklift truck and plus operator with one AMR?
Yes, sir. So usually the current situation
Let's
is
say 1 ton load maximum.
right. So current situation is that AMR with forklift capability is around, let us say, 15 lakh rupees, sir. Just for simplicity's sake. The forklift is costing 5 lakh rupee only in India, 5 lakh, right? So the operator is also low cost. It's an OPEX anyways. Now the problem is it is not likes to likes comparison in terms of cost, because the human labor cost in India is very low, so it does not qualify to be compared. But the problem here is that the forklift operators are not available easily.
Yeah.
So, and also sometimes what's happening is AMRs are not compatible in the floors that are designed like 30-40 years ago, which are very tight spaces are there, then very difficult for it to do the job. And the floor, depending on the floor evenness also, it depends.
Yeah. No, not only that, I'll put it in a different fashion.
Right.
Quality and accuracy with AMR will be much better
Yes.
in terms of transport of material as compared to the forklift. The operator
Definitely.
can make mistake, he can get into a safety problem, and so many other things.
That is
Yeah.
absolutely right, sir. Because we see a problem already with this kind of, forklift operators will place it somewhere in the rack and they may forget, but the robot will not forget where it has placed.
Okay. Good. Thank you.
Yeah.
Is
I
there
think there
any
were
other
a couple
question?
of one question is there. I think 1 or 2 questions. I'll just answer this, sir. Which area of aim? Okay. The last question is. First question is. AMR was used in hospital during Corona. How is it used in current situation? So current situations, actually there are discussions around. There is someone called running nurse. Basically, in operation theaters, people want material that is coming from going out, getting some material back and forth. So a robot can go quickly and come back and get some material from outside. That is something that is in discussions, right now. Next is I'm a CSC student. Can you please explain how to start programming phase in the AMR? I would suggest to start with I will share the resources. I think it is already shared, I believe. The construct sim is the very good starting point. You can go there and you start learning, and it will be easy to navigate. Projects should student build. So yeah, you need to build projects. uh, the AMR itself is a project. Actually, you should start making one. If you are not capable of mechanical aspects, you should be able to do only software side of things, and then slowly get into electrical and then mechanical. Right? There is another question is, in your opinion, which area of AMR still have the most significant limitations, and where do you see the greatest opportunity? So, like I was saying, the biggest problem is our factory floors are not even. That is the biggest challenge that we currently see for adopting the AMRs. Otherwise, there is a lot of scope. In warehouse, it is already flooded. In warehouse, it is most of the warehouses are sorted. In factory floors is where there is a lot of opportunity for small and medium scale companies also. There is one person dedicated to move material, and sometimes these people don't come to work. Then that is a big problem. So SMEs are something that we can easily target. So how can you say that robot accurately goes to the assigned ward during emergency or urgent situation? So actually, robot has coordinates. It will actually, it just only deals with coordinates. So it will, there is no way for it to make a mistake. If you ask it to go to ward number A and you have certain coordinates, it is just like you start Google Maps and set to Charminar. There is no other way it will show a different route, right? Simple as that. So it will not show stadium if you are selecting Charminar. So same way, it will path plan that. But if there is some obstacle, it will not be able to reach. If someone moves it or something happens, but still it will try to recover because it has a lot of sensors on it, right? It will recover. Yeah. I think we are out of questions.
Okay. I think we are done with the questions, sir.
Okay.
Yeah. Okay, I think we had a very interesting session, and it was a total view of how water in AMR is, how it works, what are the parts, how it is designed, why those parts are there, and then application, all that. It was a very concise presentation given by Mr. Nithin, and I would like to congratulate him for having put everything together in a nutshell in an hour's time, hour and a half. So I'm
Thank you
very
so
happy
much.
about it. Thank you very much, Mr. Nathan, and also the participants who have gathered in large numbers, in thousands, who are listening to you, and some of them ask questions. I think fairly the question and answer session has also been good. Thank you very much. Thanks a lot. And I thank PMO, Mr. Kishore, for having organized in a very good manner. Thank you.
Thank you,
Over
sir.
to Kishore.
Thank you, Mr. Nitin. Thank you for the session. It was a very nice session. I request the participants to give the feedback about the session. I have pasted the feedback link in the chat box. Thank you, sir.
Thanks, everyone.
We can stop the recording.
Thank you, Nitin. We will meet in person sometime.
Right. Thank you.
Thank
Bye.
you. I am from manufacturing. I know automotive.
Yes, sir. I know
I've
that.
been in automotive for the last maybe
Yes,
5,
sir.
6
You
decades.
mentioned that you designed the L&T machines
Yeah,
for
yeah.
MRF.
Thank you.
Yeah. Thank you, sir.
Thanks.